So today we are solving polynomials for our upcoming test. Look at number 1. This one is actually dividing polynomials, so we're not quite to the solving ones yet. And I look and I have the same thing top and bottom. So it's important when you're trying to cancel a denominator like 2x plus 3, notice there's two terms there. It's important that you find the exact same term on top to cancel. So I'm going to jump to number 3 instead of number 2 because number 3 is just like number 1. I've written it a little bit different. It says quotient, but quotient means divide, so we know it's going to be the same type of problem. So let me set this up a different way. This is really x squared minus 7x plus 12 all over x minus 4. Now I would go ahead and make sure anytime you have a binomial in the denominator, make sure that you put parentheses around that so you don't accidentally just cancel half of it. We can't just say 12 divided by 4 here. We have to cancel x minus 4 with another x minus 4. So that brings us to factoring. Now I'm going to bring up some scrap paper here so that I can write nice and large, and I want to factor just the top of my fraction there. So I know that my a is 1, my b is -7, and my c is 12. So my a was a ninja, and then -7, and then 12. I'm going to multiply my a and my c, so I get 12 there, 1 times 12. And then I'm going to break that apart again, and looking for two things that multiply to 12, but add to this -7. So thinking of them, and I get -3 and -4. I knew they both had to be negative, so that they multiply to a positive but added to a negative. Now I'm going to my 2 by 2 box. My first term goes in the first box. My last term goes in the last. I'm going to split up that x into two places using those two numbers I just found. So I'm going to put my -3 and my -4 in there. The order of those doesn't matter. We'll get the same thing in the end. So I'm going to pull out the GCF to the side. X squared and x have an x in common. GCF out to the side again. 3 and 12 are both divisible by 3. And anytime your first thing's negative, you pull out the negative right away. Then let's see what's left over. When I pull out my x, I get an x and a -4. When I pull out that -3, I also get an x and a -4. That's exactly what I was looking for. So I found out that my polynomial right here was really equal to my two factors, x minus 3 and x minus 4. So I need to divide that by x minus 4. And we can see the cancellation. So your final answer would just be x minus 3. So let's go to number 2 now. This one's a little bit different because I don't have two terms on the bottom. I just have that one thing. So when I just have that monomial, I can split it up and divide each of my top things by it. So I'm going to take my first term, that 10x to the 4th, and divide it by 2x squared. I'm going to take that 6x cubed and divide it by 2x squared. And I'm going to take that -2x squared and divide that one by 2x squared as well. So I've rewritten this. It still says the same thing. Everything divided by 2x squared, and everything's getting divided by 2x squared. Now I just need to divide. So I'm going to put my final answer up above. My 10 divided by 2 is 5. I'm going to cancel my bottom two x's by subtracting. So I really have x squared left over. 6 divided by 2 is +3, so I'm going to say +3. Had 3 x's, going to cancel 2, so I still have 1 left. So that was subtraction again. And finally, and this is where some people messed up on our last quiz, yes, the x squared cancels here, and yes, 2 over 2 cancels, but we have to write something there. So -2 divided by 2 is still -1. So when it's the exact same thing, top and bottom, you should still have a 1 left over. You can't lose that term entirely. Number 4, same type of problem as number 2, but I've written it with the word quotient. So this is telling me to divide. So where do I divide? It's wherever that and is. I'm dividing by a monomial just for x. So I'm going to split it up just like I did. I'm going to go right to my problem right here so I don't have to write it again. And divide that 4x into everything. 16 divided by 4 is 4. Had 10x's, canceled 1, so I have 9. Negative 8 divided by 4 is negative 2. Had 6x's, canceled 1, so I have 5. 20 divided by 4 is positive 5. Had 5x's, canceled 1, so I still have 4. So that would be your final answer for that one. The next section says to solve these factors. Now, when it's equal to 0, so make sure this is always equal to 0 before you even start, we have a quick trick to solve. We know what the solutions are. When we look at the factor, all we have to do is switch the sign. So we say, okay, this is positive 2, so my solution is going to be the opposite, negative 2. This one says negative 7 in my factor, so my solution is going to go backwards, and I'm going to say positive 7. So it's always the opposite sign. We use these brackets to just put them all in, saying these are all the solutions to this problem. Now number 6, a little bit different, because I have these coefficients. We're going to start it the same way and then just add an extra step. So when I see a factor that says minus 4 or negative 4, I'm going to write the opposite, positive 4. And then that coefficient becomes your denominator every single time. So comma, for my next one, that one says positive 5. So I'm going to say negative 5, and then I'm going to divide by my coefficient again. If it ever happens that these fractions are not reduced, please reduce them. Make sure those are simplified fractions. For number 7, we're getting another 2 solutions. Anytime you see 2 x's, you should have 2 answers for x. And our second one there is pretty easy. If it says plus 4, you know that's going to be negative 4. But here's the one a lot of kids are missing right there, 6x. That's a GCF with a variable in it. You always know that answer is 0. So 8, very similar, but this one says y, so I'm going to say y equals. I've got a GCF with a variable in it, so I know that y is equal to 0. And this other y right here is equal to positive 10 because it started as a negative 10. Now we can go the opposite way. I've actually given you some zeros, so you could call these solutions or you could call them roots. They're all the same thing. I can give you these, and we can go backwards and write our factors because we know what factors look like. We have these 2 sets of parentheses. I know what my variable is supposed to be. And I can just reverse the signs one more time. This positive 2 must have came from a negative 2, so minus 2. This negative 8 must have came from a positive 8, so we say plus 8. And there you go. You have your factors. For 12, I see some fractions. So the only way I'm going to change this up is when I write my x, I'm going to leave a little space in front because I know I'm going to have a coefficient. Same thing for the second factor. I'm going to leave a little space in front because I know that I'm going to have a coefficient because it's a fraction. So let's look at 2/3. I know my denominator goes in front of my x. That's where we got it from. And then it says positive 2, so I'm going to say negative 2 or minus 2. Second one there, my denominator, that 9, is going in front of the x. It says negative 1, so I'm going to say positive 1. Last one, just like this. I've got 0 and negative 6. Remember what we were talking about on 7 and 8, though? Every time you have that GCF with a variable, that's where you get your 0 from. So this one's really x times x plus 6. Now I have some pictures and I've asked for you to do the same thing. So what we are going to do, so we're going to first figure out what our solutions are. So what are our zeros? And you always find those on your x-intercepts. So your solutions, your roots, your zeros are the same thing, and they are found on a graph at your x-intercepts. So my x is equal to 2 and 6 on this one. So I found that one on 2. I found that one on 6. So if I want to write the factors, which is what this one asked for, I need to go backwards on that. And say this is really x minus 2 and x minus 6. That was a very missed one on the last quiz. We made sign errors. We put the signs as we saw them, but these are our solutions, and I asked for factors. For the next one, I see two solutions again. I've got x is equal to -1 and +3. Which means my factors, opposite signs, +1 and -3. So x plus 1, x minus 3. For our next section on here, it says solve the following using square roots. So that's what we're going to do. Now some of these you could factor with difference of squares. That's another technique to go through these. But I am just going to do these with square roots so that we can practice that skill. So I'm going, when I see x squared, I'm going to cancel that with a square root. So I no longer have x. And the square root of 225 is 15. But you've got to remember on these, you've got to say plus and minus. So whenever you take a square root, you say plus or minus, because 15 squared is 225, but so is -15 squared. So we're going to get 2 answers for all of these when we take that square root. Let's look at number 15. First thing, I need that x squared by itself. So I'm going to divide by 4. It's gone. I have x squared equals 81 over 4. Now I didn't divide that because I said whole number, simplified fraction, or simplified radical. I do not want a decimal. And that doesn't divide into anything other than a decimal. But this is a special one because look, we've got a perfect square over a perfect square. So when I go and take this square root, instead of taking one big square root, I'm going to break that up into 2 little ones and take each the numerator and the denominator separately. So I'm going to get x. We get that plus minus we were talking about. And then the square root of 81 is 9. The square root of 4 is 2. Let's look at number 16. I've got to get that x squared by itself. So the first thing I'm going to do is add 1 to the other side. Now I've got 2x squared equals 40. Still got to get rid of that coefficient, so I'm going to divide by 2. So x squared equals 20. Now here we're running into 20 is not a perfect square. So when I take this square root to get rid of my x squared, I'm getting plus and minus root 20. I can't actually give an answer there that's not a decimal. So it says simplified radical in our direction, so that's what I'm going to do. I'm going to break this down into my factors. I've got 5 and 4. 5 is prime, 4 is not. So I'm going to break that one up again into 2 and 2. So to simplify your radical, anytime you see a pair of numbers, that's like taking the square root of 4 right there. So we're going to move that out to the outside of my radical. So I keep my plus minus, I keep my square root. And the pair of 2's, you put it outside. Only one of them though, right? Square root of 4 is 2. Anything left over goes inside. So you say your x is equal to positive negative 2 root 5. Let's go on to the next one. Just have a coefficient there, so I'm going to divide by it. And x squared equals negative over a negative cancels, so that's a positive. 2,000 divided by 5 is 400. Take your square root here, and you get that x is equal to, don't forget your plus and minus, so your positive, negative. Square root of 400 is 20. If that one was a perfect square, we can solve it right away. Number 18 is another one that is not a perfect square, so we're going to have to simplify that radical. But before we get there, we're going to subtract our 16. That gives us 36 and 3x squared. So we're going to divide by our 3. And x squared equals 12. Don't leave it there. You've got to cancel that x squared. So I'm going to take the square root of it, gone, and x equals the root, positive and negative, of 12. Going back to our factor tree on this one, I've got to simplify this one if I can, so let's do a check. I've got 4 and 3. 3 is prime, 4 is not. 2 and 2, those are both prime. So I'm seeing a pair of 2's. So when I write my answer, I'm going to write that 2 outside, and leftover 3 goes inside. So there's your simplified radical.